So in this lesson today, our goal is to calculate once again the area of a regular polygon, but we're going to be given the radius and also a side. So we're still going to use that same formula or tool that we learned in the last lesson. So the area is going to equal to 1/2 times the perimeter times the apothem. Well, if you notice in our formula, we have a perimeter and the apothem. However, we don't have the radius, but we can use the radius to help us solve for the area. So the radius is still the same radius that we talked about in the past. It's just a line segment from the center of the circle to the edge. Now, all we're doing now is just describing a regular polygon inside the circle. And if you notice, they both share the same center and they both have a radius, but with the radius for the regular polygon, that it actually connects to the vertex of our polygon or the corner. So we're going to use a hexagon to use as an example to understand this concept a little more. Now with our hexagon, and I'm sorry I have to tilt it a little bit, we can actually still create a radius for that even though it's not given to us. So let's go ahead and let's put our center on our hexagon. And let's go ahead and let's draw the radius from the corner to the center point of our hexagon. So this right here is our radius. Even though we're going to do some examples that don't give us our apothem that we need, we can still figure it out and draw it in. So let's go ahead and let's take from our center point to the side, and that's going to be our apothem. Remember, our apothem is always going to be perpendicular to the side. And I'm just going to go ahead and label our side so we just have everything labeled. If you notice the relationship with our side and our apothem, like we mentioned before, it is perpendicular, but it also splits our sides in half. So those two parts are going to be congruent to each other. Now take a step back and just see if you notice anything that you see. I don't know about you, but I see a right triangle. So there might be a useful tool that we talked about in the past that can help us. Now, if you're thinking Pythagorean theorem, then you totally read my mind. So we can definitely use Pythagorean theorem to help us find the apothem. Now we need to think carefully who are going to be the legs, so A and B, and who's going to be our C, the hypotenuse. And remember, the hypotenuse has to be the largest number in the right triangle and also across from a right angle. So the only thing I see that's across from a right angle is actually going to be the radius. So that leaves us part of that, or half of the side, and the apothem for our legs. So it doesn't matter who you label A and B as the apothem or half side, just know those two have to be our legs. Just like a circle, we can have multiple radii. Even though it's shaped, we're still going from the center point to the corner, so we can actually have multiple radii, but we're going to be limited depending on the particular polygon. In this case, we have a hexagon, so we're actually able to create 6 radii. So if we kind of take a step back and kind of state the obvious of what we see, we can see that there's multiple triangles in our regular polygon. So before spring break, we did calculate how to find the area of a triangle. And if we look, we're using an example with a hexagon, so if we look at the bigger triangles, we have about, no, not have about, but we have 6 triangles. So if we find the area for one of them, we can just multiply that by 6. And that will actually give us the area for the whole polygon or the hexagon. So that is just one example to help us show how that generic formula works. Let's just investigate a little bit further and see if we can come back to that generic formula. So we're just taking the area of one of those triangles and multiplying it by the number of triangles we have inside that regular polygon. So we should know the area of a triangle. Remember, it's going to be base times our height. But if we look, the height of our triangle is going to be the apothem. And then the base of our triangle is going to be the side of our polygon. So the A is the apothem, S is our side. Now, with the number of triangles, we can just represent that as the letter N. Because N usually means the number of sides with our polygon, and if we notice, the number of sides and the number of triangles are the same. So for example, with our hexagon, we have 6 sides and we have 6 triangles. Now we can simplify this a little further. So we can still do 1/2 times the apothem. Now when we multiply the sides and the number of sides together, that actually gives us back our perimeter. Now if we just simplify it even further, we're back to what we talked about at the beginning with our formula. So I just want you to understand how that formula works and where those concepts come from. Awesome. So now that we know the deets to our formula, let's go ahead and let's apply that, trying to find the area of a regular polygon when we're only given the radius and its side length. So even in this particular problem, I'm still going to use that formula or that genetic formula to help me find the area of my regular polygon. The only unknown that we don't have in that formula is our apothem. So I'm just going to put a little question mark right there because I need to find him in order to solve this problem. If you recall from earlier, we can actually use our radius and our side to help us create a right triangle. And when that happens, our apothem that is unknown, will split our side in half. So I'm going to put those little marks to let you know they're congruent. So now that we create a right triangle, we can use Pythagorean theorem to help us solve for the apothem. Even though I need to find the area, I have to find my apothem first. Now you don't have to if you want to, but it helps me. I like to redraw my right triangle so I can see who's my hypotenuse and who is my leg. Now remember, your hypotenuse has to be the side across from the right angle. And we talked about the apothem and half of the side of our polygon being the leg. So be careful when you label your parts. So if you notice, our radius is 8 and he's across from the right angle in our right triangle. So he is going to be our hypotenuse. So now our legs are going to be our apothem. And then also our side, half of our side, which is 9.4 divided by 2, and that gives us 4.7. So the other leg is going to be a length of 4.7. So next we're just going to apply Pythagorean theorem. So a squared plus b squared equals c squared. So be careful who you label as your legs and your hypotenuse, because that's really important. Now your apothem, you can make it a or b, it really doesn't matter. I'm just going to leave it as a, so a squared plus, and I'm going to have 4.7 represent b, so 4.7 squared is equal to 8 squared. Now let's just simplify that. So now we have a squared plus, and then when we square 4.7, we get 22.09 is equal to 64 because 8 squared is equal to 64. So I want to get a by itself, so I'm going to subtract 22.09 on both sides. So now I have a squared is going to equal to 41.91, and we're going to take the square root of that because I want to get A by itself. So now A is going to roughly equal to, if I round to the nearest tenth, 6.5 inches. Right, so that just gives me my apothem, which I can now plug it in to my general formula. Right, so we have our area is equal to 1/2 times the apothem we found. So that's 6.5 times our perimeter. So now I'm actually taking 9.4 because that is the length of my side for my pentagon, and a pentagon has 5 sides. So I'm going to multiply my side length of 9.4 by 5. So once again, 6.5 is my apothem, and 5 times 9.4 is representing the perimeter. All right, let's go ahead and let's simplify. So we have 1/2 times 6.5, and 5 times 9.4 gives me 47. And if we continue to solve, we have 1/2 times, and then 6.5 times 47 gives me 305.5. But when I divide that by 2 or multiply it by 1/2, our final answer should be 152.75 and then inches squared because we're talking about area. And that's my final solution.